Assalamu alaikum. Okay, first of all, I'll be covering very basic vectors. Those of you who already know the basis can skip this part. I'll add timelines later in this video. First section is representation of vectors. There are two ways you represent a vector. For example, you are given with vector. You can label them with capital letters as A, B. Or you can label a vector with a small letter, suppose B. Moving on to the next part, vectors on Cartesian plane. Suppose you have a representation of vector which is already there and you are asked to write the vectors as column vectors. So PQ, you can write PQ as this is 4 units to X and then 3 units to Y. It is 4 and 3. Always write the X first, then the Y part. And when it is PQ, P is always the starting point and Q is the ending point. In case of RS, it starts from R and it ends at S. At R it moves 2 units to right, that is X, and in Y it moves 6 units downwards, so -6. For example, you are asked to draw a vector AB which is -2, 3. So you can start from anywhere you wish. Let me choose, suppose this is my point A, so -2. It would move 2 directions, 2 units in negative direction, and then you have +3, so it moves 3 units upwards. This would be your point B and this is AB. This is how you draw vectors on a Cartesian plane. How to find the magnitude of a vector? The general formula is x square plus y square whole square root. For example, if you are given with a vector AB whose x and y are 3 and 4. So to find the magnitude of AB, you need to use this formula x square plus y square whole square root. Just plug in the values and get your answer. You may have different values. For example, AC is 1, 3. In case when you don't get a perfect answer, so magnitude of AC would be 1 squared plus 3 squared whole square root, which is square root 10. So leave your answer as it is or as specified in the question. You may also write units with them. Equal vectors. See for yourself, you can see vector A, vector B. They are equal in length and their base vector is also same. For example, if I need to write a column vector for A, it is 2 units in X direction and 4 units in Y direction, both positive. So it is 2, 4. If I look at B, B is again 2, 4. You just count them. When I look at C, now C starts from here and C ends at this point. First count the x-axis for C, it is -2 and -4. We can also simplify C as -1, 2, 4. So if I need to write, I can say A is equals to B, and in case of A and C, I can say A is equals to negative of C. You need to understand one more thing. If you are given with vector X, so negative X would be exactly equal in length but opposite to the given vector. So we can also write for E, I can write A is equals to 2 times E, because E is 1, 2. So see for yourself, if it is 1, 2, A was 2, 4. You simplify them and you see it results as equal vectors. Now D is very different. Although it has the same length, X is 2 and Y is -4. So D is equals to 2 -4. The base vectors are not same. They may have the same magnitude, but for them to be equal vectors, the direction should also be same. Addition of vectors is again a simple concept. You do have two vectors. Let us suppose we have one vector and it looks like this and I name it A. I have another vector which looks like this, and I name it B. Just for clarity, I'm writing on the other side A is x1 and y1. For B, B is x2 and y0. So if I ask you addition of vectors, if I ask you to solve for A plus B, you may choose to draw A anywhere. So let's say I start from here and I just copy this vector A, equal in size and having same direction. Then I copy this vector B where I ended A. Also, you can also call them head to tail rule. So this is A plus B. The vector started at this point, the vector ended at this point. So from start to end, your resultant would look like this. Now you have seen the graphical representation, and if I ask you to write the column vector form, so it is 3 units in x-axis and 1 unit in y. So A plus B is actually equals to 3, 1. If someone asks us to solve this, so A was, we copy from here, A was 1, 1 and B was x2, y0. So if you have to solve A plus B, it is actually 1, 1 plus 2, 0. So 1 plus 2 is 3 and 1 plus 0 is 1. So 3, 1, either you do it algebraically or graphically, the answer is same. Another thing which you need to confirm is you solve for A plus B or you solve for B plus A, you always get the same answer. For example, we start with B and this is our starting point, and I draw vector B as follows. Then I draw vector A at the head of B and A is 1, 1. Now your starting point is here, your ending point is here, so this is your resultant. Now count again. For this resultant, x is 3 units and y is 1 unit, so 3, 1. Either you solve for A plus B or you solve for B plus A, your answer is always same. The next concept is subtraction of vectors. As we've done earlier, subtraction of vector, negative vector is just the same size but in opposite direction. Repeating it again, if it is x, so negative x would be same size parallel to the previous vector but opposite in direction. So again assume the same vectors A 1, 1, B x2 and y0. So A would look like this and B looks like this, A and B. And for example, you are asked to solve for A minus B, negative of vectors, subtracting vectors. So first it is A, you draw A first, and then negative of B would mean you draw the same vector but in opposite direction. So in opposite direction, this is the direction. So this is A and this is minus B. For the resultant, it is always starting point till the ending point. So A minus B is this, A minus B. Now see if we get the same answer. If we first draw minus B, then we draw A. So we start with minus B at this point, and minus B would be in opposite direction of B. Then we have an A, so we plus add A's. Just add A in this vector and you see your resultant is, this is the starting point, this is the ending point, and your resultant looks like this. So both of these vectors are exactly the same, and A minus B is minus 1 in x direction and positive y. So this is minus 1 and 1. Either way you do, you get the same answer. And if we need to solve it here, A minus B, A is 1, 1, B is 2, 0. So 1 minus 2 is minus 1 and 1 minus 0 is 1. Next concept is scalar multiple of a vector. If you look at this vector A and then you look at these vectors B, they are parallel. A and B are parallel. Let me count for A. If I see, this is from 1 till 7. In X it is 6 units, and in case of Y it is from 2 to 14, that is 12. I'm taking out 6 as common to compare base vectors. So this is 1, 2. If I write the same for B, B starts from here, it ends at this point, so this is x3, and this height is from 2 to 8 is again 6. Now you take out 3 as common, you're left with 1 2. This 1 2 means base vector is same, so they are parallel, but I can see that 6 is 2 times more than b, so I can say a is equal to 2 times b. Now scalar multiple is this number. The vector is same, the direction is same, but the size is different. In case of C, we again do have some vectors. If I count this, this is x minus 2 and y minus 4. So minus 2 and minus 4. Minus 2 and minus 4, you take out negative 2 common, so 1 2. So base vectors again same, minus 2 outside. So we can say, if we compare A and C, you see 2 3 times is 6, so A is equals to 3C, but don't forget the direction and put a negative sign here. In the same manner you can compare B and C as well. Expression of a vector in two other vectors. Now you have this longer vector AB, which is actually the sum of u and v. How many times u is there, how many times v is there, we don't know. So let's get started. U is x1 y2, u is 1 2. So I start from A and I apply u first. So we count these boxes x1 y2. So I have this u. Then I apply another u, because I know v is perfectly horizontal, it is not getting anywhere close to b, so we apply another u and we count this box x1 y2. This is our point, and we continue till we know that we'll be reaching b. U again, this is 1, this is 2. Now I know that I've reached a point that this v will now lead me to b. Now v is x3 and y0. So this is 1v, and from here this is another v. You label them, this is u, u and u. These two are v. So now I can rightly say AB is equals to 3u plus 2v. This is again possible, you can start from any side. If we started with v, it would have been this way. Now this is v, 1v, because we know it is 3 0, another v. This is again 3 0. Now if someone cannot actually imagine that if they need to add one more v or not, you can start in the reverse way. This is u, you know, minus 1 and minus 2. So from b, minus 1, minus 2, 1 point, minus 1, minus 2 again, second point, minus 1, minus 2. So it lands here perfectly. This is not always the case. You may have answers in decimals as well. So this is 2v and 3u. You write 2v plus 3u, or you write 3u plus 2v, the answer is same. Understanding the concept of position vectors and expressing them in terms of position vectors. So what actually position vectors are? If you have this Cartesian plane and you are given with few coordinates, let's say A is x2 and y3 and B is x3 and y minus 1. So we just assume that in positive direction 2 and 3, A would somehow look like this, and for B, x is 3 and B, y is minus 1. So this is B. So what position vector is actually? It is the position of any given point from the origin. So when point A is given, vector OA from origin, vector OA. So position of A from the origin is 2 3. Then we have vector OB from the origin. The position of vector B is this. So this is 3 minus 1 position vectors. Now see, if we need to find the resultant or we need to find AB, this is, we start from A, so it is AO plus OB. We will do this in detail in the next example. You rearrange them as position vectors OA, so I am reversing this sign. This becomes OA. When I change it, I have to add a negative sign, plus OB. and you just rearrange. This is OB minus OA. Note this thing, it is always same. It is always same. For example, you are asked about PQ. It is always same. Second letter first, then the first letter. So second letter OQ minus OP. If you're asked for XY, it is always the same, OY minus OX. So you can use this grid. Let us choose the same numbers 2, 3, and for B it is 3 minus 1. So X2 and Y3A appears here on the grid. For B, X3, Y minus 1, B appears here. Now we just compare this. If we have to find AB, if I have to find this point, then record X first, this is 1, then Y, this is minus 4. So AB is 1 minus 4. Now if you look at this algebraic form, OB, we copy this OB, that is 3 minus 1, then negative, copy this OA, that is 2, 3. Now 3 minus 2 is 1, and minus 1 minus 3 is minus 4. So this is 1 minus 4, and C, that is 1, and this is minus 4. So you do it either way, you always get this same answer. Now this is an example to clear the concept with parallelogram. Let's draw one. This should look like this. Okay, let's make it a little bigger. Okay, now this is your parallelogram, and if I label the corners as A, B, C, D. Having said that it is a parallelogram, you know that these are the pair of parallel sides. Let us give it some names of vectors. Let's say AB is equals to P and AD is equals to Q. We'll keep labeling it so you don't have to look here and there again and again. Now if someone asks you about the vectors AC, so AC is, I have to start from A and I will end at C. So AC, my path would be AB plus BC. So AB plus BC. AB is vector P. You see BC is actually equal to AD. It is parallel and equal in size, so the vector is same. You just copy this. So AC is P plus Q. You might choose a different path, AD plus DC for AC. So AC, you start at A, you move towards D, then you start from D, move towards C. AD is Q and DC is equal to P. So you always get this same answer whatever path you choose. So for example, if you have some more data and it looks this way. If I give a point here which is E and I tell you that it is the midpoint of BC and they ask you about AE. So now AE is actually AB plus BE. If we have to start from A and end at E, so it is AB plus BE. Now AB plus BE, AB is P and we know that it is the midpoint, so BE is half of Q. Now again, just to compare, it is already done. This is the final answer. Just to compare, if you would have chosen a different path for AE, let's say you come from this side, right side, AD plus DC plus CE. If you do this, so AD plus DC plus CE. AD is Q, DC is equal to P because it is equal to AB, so that is P. Now CE. For CE, we know that it is going opposite to DA and half of that. So it is negative Q by 2. Now you simplify this. P is here. Now 1Q minus half Q is again 1 by 2Q. So whatever path you choose, you always get the same answer. Last example for this concept. If we label this hexagon A, B, C, D, E, F, you must know that if you mark a point at this center and you join all these sides, it would result in equilateral triangles. That is the geometry of regular hexagon. It would be equilateral triangle, all angles of 60, all sides equal in length. And now understand the vector part. If we label AB as P and we label AF as Q. Now first to clear, which vectors are equal to AB or P? So vector P, AB is P and it is equal to ED. You see, ED is also equal in length to AB and in the same direction as AB. So this is P. If we label this center as O, FO is P, OC is P. So we have these vectors 1, 2, 3, 4, which are equal in size and in the same direction. Now let's see for Q. AF. Q is equals to AF. Now this is 1, 2, 3, 4. These are the 4 vectors which are equal to Q, equal in length and in same direction. So now let's find AC. If we need to find AC, I'm starting from A, I'm ending at C. So I know I can take this path AB plus BC. Now see that BC is unknown. We know what AB is. So let's get started. AB is P. For BC, because BC is unknown, I am selecting this path that BC is BO plus OC. So that's BO plus OC. Now see for yourself that BO is actually equal to Q and OC is equal to P. So the final answer is 2P plus Q. Now we know that AC is 2P plus Q. Someone asks you about FD. You can see, because you know the geometry of hexagon, that FD is equal to AC. So you straight away write 2P plus Q in the same question. Thank you so much. We'll be continuing it with past paper questions in the next video. Take care. Allah Hafiz. In our previous video, we covered the concepts of vectors, the basic ideas, addition of vectors and all. In this, we'll be solving past paper questions. So let's get started. This is a parallelogram OACB. And you see that OA is A, then OB complete is B. Then there are points P and Q on OC such that OP is equal to PQ is equal to QC. So OP, PQ and QC. Always understand the question first, then start. So if these are equal, for myself I'm labeling it like this, that these are the equal parts. It says express as simply as possible in terms of A and B. OP. Now OP is 1/3 of OC. So I'm writing 1 by 3 of OC. For OC we start at O and we end at C. So this is the path we'll follow, OA plus AC. From the diagram you can see OA is A and AC is parallel to OB and equal to OB. So that's B. So 1 by 3 A plus B. You have to highlight the vector with this dash. I'll just skip this part for now. So BP, second part is solve for BP. So we start at B, BO plus OP. Now we see BO is minus B and OP is already there, which is A by 3 plus B by 3. Rearrange and solve. So minus B plus B by 3 plus A by 3, and you get minus 2 by 3B plus A by 3. Show that triangle OAQ and CBP are congruent. OAQ. So we'll mark our two triangles first. This is OAQ. One of the triangles is this. The other is CBP. So this is C, this is B, this is P. We have to show that these two are congruent. Let me solve it here so diagram stays in front of us. So for congruency, I'm saying that OA is equal to BC, as these are the sides of parallelogram. And next thing, I can say AOQ, the angle AOQ is equal to PCB. These two angles are equal as they are alternate angles. First angle, second angle. Then I can say that OQ is equals to PC, the length again. So two sides an angle. So by side angle side, they are proved congruent. Next question. In the diagram, A is the midpoint. So if A is midpoint, we'll mark that these two are equal. Of OC and B is the point on OD such that OB is 1 by 3 of OD. So this is 1 and this is 2. Express as simply as possible in terms of A and B. A, B. So we start from A and we end at B. So this is the path I'll choose. So AO plus OB. AO, we're going opposite to that, so that is minus A plus B. So B minus A. Next is CD. For CD, we start at C, we end at D. I'll select this path, that is CO plus OD. Now we've already given that this is the midpoint. So CO is 2 times A, and don't forget the direction is opposite. So this is minus 2A plus OD. Now OD is 3 times OB. 1, 2, 3. So that is 3B. So 3B minus 2A. Moving on to the next part. It says E is the point on CD where CE and ED are 1:2. So CE and ED is somewhere here that it should look like this 1:2. So we suppose that E is here. And what is the requirement is express BE as simply as possible in terms of A and B. So this is B. This is E. If I have to find BE, there are two paths we can take. One, and this is the second path. So I'm selecting the longer path for now. This is BO plus OC plus OE. So BE is equals to BO plus OC plus CE. BO is negative B. OC is 2 times A. Now CE, we know that CE is 1 by 3 of CD. We already have this CD. So this is 1 by 3 of CD. Now we simplify this. That is minus B plus 2A. Now 3 by 3 is plus B. That is minus 2 by 3A. You take away this B, and 2 minus 2 by 3 is 4 by 3 of A. So 4 by 3A. What special type of quadrilateral is ABEC? Now just notice that BE, whatever BE is, it is only A and not B. So OC is only A, just clear this diagram. You see OC is only A and BE is only A. So this was 2A, this was 4 by 3A. So these are parallel vectors. If these are parallel, this shape is known as a trapezium, because it is four-sided with one pair of parallel side. Next question, AD is 6, 1. This is AD, which is x6, y1. Calculate the magnitude. So 6 squared plus 1 squared whole square root 36 plus 1. So this is square root 37. Second part says AE is 1, 2. This is AE and we are given with 1, 2. H is the midpoint of AD. If it is the midpoint, let us mark. So find EH. If I have to find EH, we choose this path. So that is EA plus AH. Now AH is unknown, but we are given with this idea that it is half of AD. Now just plug in the values. EA is -1, -2 plus half of AD is 6, 1. Just simplifying, -1, -2 plus 3 and 0.5. So you're left with 2 and -1.5. So we know that EH is 2 and -1.5. Next part for the same question, BF is 1.50. This is BF. X is 1.5, Y is 0, perfectly horizontal. And CG is 0.5 and -1.5. So CG is 0.5 and -1.5. I'm writing it here so you don't have to go back again and again. Find F. F is the midpoint of BC. Okay, if this is the midpoint, we can again label like this. Find FG. So for FG, you see FG is equals to FC plus CG. This is FG, which is equals to FC plus CG. So now FC is equals to FB. So we copy this number 1.50 and CG is already given 0.5 and -1.5. So when you simplify, when you add these, this is 2 and this is -1.5. 2 and -1.5. So 2 and -1.5. Next part says use the answer to part 2 and part 3. This is 3 and this is 2. 2 minus 1.5, 2 minus 1.5. Both are same vectors, so that means they are parallel. So what we write about line EH and FG. So this line right here EH and FG, because both vectors are same, base vector is also same and the numbers are also same, so they are parallel and equal. So they are parallel and equal. Given that E is the midpoint of AB, where is E? Okay, E is the midpoint of AB, so these two are equal. And show that G is the midpoint of CD. So if we have to show that G is the midpoint of CD, we need to find CD first. Let's change this color. Okay, now working for CD. Let's say CD is EB plus BA plus AD. So BE is -2 of this. So -2 of 1.50. And BA, we already have AE, that is 1, 2. And this is the midpoint, so it doubling this would mean 2, 4, but it is in the opposite direction, so we use negative sign with the 2, 4. then AD is already 6, 1. So just add these, multiply this first, -3, 0, and this is -2, -4, and this is 6, 1. Now -3 minus 2 is -5, -5 plus 6 is +1. Now 0 plus -4 is -4, and 1 is -3. So we have to show that G is the midpoint. So now CD is 1 minus 3. If you just divide it by 2, you get 0.5 and minus 1.5. So it is shown that it is the midpoint. Or you can do it in reverse manner. You can multiply it with 2. You get 1 and minus 3. And now these vectors are equal. This and this. So shown. Next question. B is the midpoint of OD. If it is the midpoint, these are equal. And E is the midpoint of OA, so these two parts are equal. C is the point on AB such that AC ratio CB is 2:1. OA is P, OB is Q. Find in terms of P and Q. AB. So we start at A and we end at B, so AB is AO plus OB. AO plus OB. Now AO is minus P and OB is Q. So Q minus P. Next part is CD. For CD, I'm writing CB plus BD. CB plus BD. Now we know CB is 1/3 of AB. So 1/3 and copy AB from the previous part, Q minus P. And BD is equal to OB, so that's Q. So Q by 3 minus P by 3 plus Q. Rearrange Q by 3 plus Q minus P by 3 and solve this. So 1/3 plus 1 is 4/3 of Q minus P by 3. You can also take out 1/3 as common if you wish. Makes no difference. ED. Okay, for ED, we start at this point and we end at the top. Now ED is EO plus OD. EO plus OD. EO is half of P. So negative P by 2 because it is coming in the reverse direction, and OD is 2Q. So plus 2Q. So if I take out 2 as common or 1/2 as common, I'm left with negative P plus 4Q. So half of 4Q negative P. Before moving on to the next question, we can still see what it would be. Use your answers to part 1B and 1C to make two statements about point EDC. Now you see these vectors are actually equal. So first thing we can say that CD and ED are parallel. They are parallel. And second statement is the scalar part. This is 1/3, this is 1/2. LCM of 3 and 2 is 6. If you multiply both of them with 6, this will become 2 and this will become 3. And then you can compare the sizes. So we can say ED and CD. ED and CD. So I can say 2 times ED is equals to 3 times CD. First thing was they are parallel. Second is this scalar multiple. Next question. Express A plus 2B as column vectors. So just copy these values, 3 minus 4 plus 2 into -1, 7, and simplify. So 3 minus 4 minus 2, 14, 3 minus 2 is 1, and that's 10. So this is 110. Find magnitude of A. A is 3, 4. So 3 squared plus minus 4 squared whole square root, 9, 16 square root, 25 square root. The answer is 5. Given that magnitude of B by magnitude of A is equals to square root n, solve for n. So B is minus 1, 7. So let's do this. Minus 1 squared plus 7 squared whole under root is 1 plus 49, and that's square root 50. So B is square root 50, A is 5, and equals to square root n. So if we take square on both sides, this is 50 by 25 is equals to n, and n is equals to 2. Next question, probably the last one. So in the diagram, OQ is equals to QS. So these are the two main points. QR is equals to 2 times PQ. So let's label them with numbers. So if this is 1, this is 2, and ST is equals to 2 times RS. So if this length is 1, this length is 2. Express as simply as possible in terms of P and Q, or Q, OQ. So OQ is OP plus PQ. So that is P plus Q. Let's save some space. And RS is RQ plus QS. Now we know RQ is in opposite direction of PQ, and it is 2 times that value. So minus 2Q, and then QS is actually equal to OQ. So we just add this OQ here, and then you simplify. This is P minus Q. OS is 2 times of OQ. So just multiply this, 2 times of OQ. OT. So we start at O and we end at T. So that is OS plus ST. Now copying OS from the last part, 2P plus 2Q, and ST is twice of RS. So this is RS. So twice of RS, directly write 2P minus 2Q. Now simplifying this, we get rid of this, and this is 4P. Hence write down the two facts about OP and T. This is the same question as we solved over here. So when you see that the vectors are same, first fact, they are parallel. Please excuse this, he didn't ask about the vectors. So if it would have been a vector, you will write they are parallel, and how many times. Now you see that this is also P and this is also P. So I can say they lie on same line, because they start from the same point and the vector is also same. Second thing, you say OT is equals to 4 times OP. Question number 14. This would be a trickier one in the last part. Find A and B. Okay, this is QR. So this is 1 and minus 3. That is 1, that is minus 3. Magnitude of PQ, that is 5 square plus 2 square whole square root. 25 plus 4 is square root 29. OACB is a parallelogram. OA is A, OB is B, D is the point such that OB is 2 times OB is BD. So 2 times this is 1, this is 2. Express CE as simply as possible in terms of this. Now, okay, E is the midpoint. So for CE, that is half of CD. For CD, I can say that CB plus BD. So CB is minus A and BD is 2 times B. So you can copy it as it is, or you may simplify. So that is B minus a by 2, that is CE. Next part says express OE as simply as possible. So we start from O and end at E. So I find this the easy path, OA, AC and CE, because I know all the values. So OA plus AC plus CE. Now OA is A, AC is B, we're copying it from here, and then CE, we've already done that, that is B minus half of A, so that is positive half A plus 2B. Okay, now the last part, F is the point on BC such that OF is K times OE. So OF is K times OE. This actually means they lie on the same line. So find BF ratio FC. So first we'll find BF. So for BF, I'm selecting this path BO plus OF. So BO is minus B and OF is K times OE. Now you just copy this OE from the previous part. So multiplying with K, you'll have greater space in the actual exam than it is here. So minus B plus K by 2 of A plus 2KB. Now if you rearrange, we see that it is 2K minus 1 times B plus K by 2A. Now please notice that BF, whatever BF it is perfectly parallel to this vector A. That means there's no part of vector B. So this vector B right here should be equal to 0. 2K minus 1 times B is equals to 0B. So 2K minus 1 is equals to 0, K is equals to 1 by 2. So when you know it is K 1 by 2, you place this K 1 by 2 here and you get 1 by 4 of A. So if it is 1 by 4, this should be 3 by 4. And the question demanded BF ratio FC. So BF ratio FC is 1 ratio 3. I will look at one more question. In the diagram, ABCD is a parallelogram. So ABCD is a parallelogram, and P is the midpoint of BC. So it is already marked 1:1. Then Q, DQ and QP is 1:2. DQ and QP is 1:2. AB is equals to P, AD is equals to Q. Express DP in terms of P and Q. So we start from D and we end at P. So I'm taking this path. So DA is minus Q, AB is P, and BP is half of Q. So when you simplify, you get P minus half Q. Second part, express DQ in terms of P and Q. So this is D, this is Q, that is clearly 1 by 3 of DP. So 1 by 3 of DP, that is in the previous part, 1 by 2 Q. So when you simplify this, you get P by 3 minus Q by 6. So 1 by 3 of P plus minus Q by 6. Next part, express AQ in terms of P and Q. Give your answers in its simplest form. So AQ is AD plus DQ. So AD is Q and DQ is in the last part. So 1 by 3 P minus Q by 6. So this is P by 3 and 1 minus 1 by 3 is plus 5 by 6 of Q. So 1 by 3 of P plus 5 by 6 of Q. R is the point on BC produced such that BR equals K times BP. So BR equals K times BP. So whatever it is a multiple of Q. It is K times BP. Express AR in terms of P, Q and K. So AR is AB plus BR. AB plus BR. So AB plus BR. AB is P and BR is this right here, that is K times of BP, and BP was half of Q. So that is P plus K into half of Q, resulting as P plus K by 2 Q. P plus K by 2 of Q. Now given that A, Q and R lie on straight line, find the value of K. Whenever you are given with these values, you always use a new constant. A, Q, R, if it lies on one line, we can say that AQ is some value times AR. AQ and AR. Now why are we using AQ and AR? Because we have these values and not QR. So AQ is H times AR. AQ is H times AR. Now we need to copy these values. AQ is this right here. So value of AQ was 1 by 3 of P plus 5 by 6 Q. H times, and then AR is right here. This is P plus K by 2 Q. Now you only have to compare the sides, the vectors. So if I simplify, this is 1 by 3 of P plus 5 by 6 of Q, and on right side is HP plus HK by 2 of Q. Now compare these vectors, P with P and Q with Q. So this is H and 1 by 3. So I can say H is equals to 1 by 3. And then compare coefficients, scalars of Q. So this is 5 by 6. 5 by 6 is equals to H, which was 1 by 3 into K by 2. So solving for K, 3 2 times is 6. So you get rid of this, and K is equals to 5. That's it. Thank you so much for watching. Take care. Allah Hafiz.